and welcome back. We're going to be talking about section 6.3 now. 6.3 is the application problems, or the reading problems, we might say, of what we've been talking about. You know, in the earlier sections, we learned how to solve equations, use the order of operations, then work with some formulas. So that was leading up to now some just general applications. So the first thing we'll talk about is a proportion. A proportion says that you've got two fractions or two ratios, we might call those, two ratios or two fractions that are equal to one another. So anything you can set up as a proportion is kind of handy. This is neat because you can then cross multiply. The cross products are always equal in a proportion. So this times this, we'll say this A times D is always equal to this times this, B times C. If you think of some proportions you know to be true, like a half is equal to 3/6, you know that's a truth. The cross products are equal there. You know, 1 times 6 is 6, 3 times 2 is 6. Let's say 2/5 is the same as 4/10. They're proportional to each other. They reduce to the same thing. So notice 2 times 10 is 20, 4 times 5 is 20. Any true ratio, equivalent fractions, they're going to be equal when you do the cross product. So that's a truth in math. So some examples of things that are proportionals, reading along in your note packet. So recipes. Recipes are usually proportional. If anybody's really a culinary arts person, you might debate that with me. Maybe doubling a recipe can mess up the exactness of it. But for us regular cooks, we usually just double a recipe or triple it. So those things seem to be proportional. A recipe that calls for 2 teaspoons for 4 servings. So if we're making 9 servings, we could set up a proportion and figure that out. Figure out how much per serving and then just double, triple, whatever we needed to do. So recipes. If you were doing weed killer, it'll have a proportion or a ratio on the directions. For example, if it takes 3 teaspoons of a weed killer for 2 gallons of water, how many teaspoons would we put in 3 gallons of water? So again, we could set that up using this strategy. 1 part vinegar, 1 part oil to 10 parts water. So ratio like that, again, kind of a recipe thing. You could double that or triple that, be proportional. Gasoline, you know, we have a per price per gallon, so that's proportional. Things that have a unit multiplier basically are proportional. There's some direct multiplier that we can put on it that keeps it the same level all the time. There's a direct multiplier involved. So say this $5 for 9 gallons of gas, you could figure out how much for 10 gallons of gas, or so on. So let's set up a couple of those examples before we move on with this idea. Let's do the recipe idea. The first one, a recipe that called for 2 teaspoons for 4 servings. Okay, there's a statement of truth that it said 2 teaspoons for 4 servings. So how many teaspoons, we'll call that X, because that's usually what we're going to be doing with these, is trying to figure out some unknown. So X amount of teaspoons for 9 servings. So teaspoons is to servings, as teaspoons is to serving. We talked about that should be a proportional thing. So again, notice I put the teaspoons on top. You could have done this differently if you're thinking that, but this will work. Teaspoons is to servings, as teaspoons is to servings. Again, they should be proportional. Once you're sure you've set things up correctly, you just kind of drop those units and do the algebra. So then we could solve this by cross multiplying and saying 2 times 9 is 18, 4 times x is 4x, and then solve that equation. You'll divide by what's with your variables, so we'll divide out the 4, and it will be 18/4. We can leave it like that or write it as, what would that be, like 4.5, 4.5 as a decimal. So reduce it either to a reduced fraction, like that or that, or as a decimal. So that seems reasonable. 4.5, that's probably what we would guess anyway if we were cooking. The next example can be set up proportional. Let's do the weed killer example. 3 teaspoons of the weed killer, whatever brand you have, goes with 2 gallons of water. So over here we should have teaspoons over gallons. So it says how many teaspoons or 3 gallons. Again, I have teaspoons over gallon, teaspoons over gallon. This should be a proportional. situation. So then we can drop these units and say 3 is to 2 as what is to 3. And use our strategy of cross multiplying. And it doesn't matter which way you go first, by the way. You can multiply this way or that way. They're going to be set equal anyway. I think I'll do the variable first this time. 2x, and then 3 times 3 is 9. Divide by 2. Oh, we got 4.5 for this one as well. Did I ask the same problem? No, it was similar though. So that is 4.5, or 4.5. All right, let's do the gallons of gasoline example. The third one I put there has more things involved, wouldn't necessarily set up quite as easily here. Let's do the dollars, $5 for 9 gallons. And then we'll do how, I think I meant to put how much money, so X amount of money for 10 gallons. Not a whole lot more, right? It's a little bit more, maybe guess, maybe $5.50. You could figure out the price per gallon, and maybe that's what we normally would do, but this is still helpful for us to build this technique of proportions. So if it's $5 for 9 gallons, then how many dollars for 10 gallons? Drop your units and just do the numbers with our proportion. You can cross multiply and say 9 times x equals 5 times 10, 50. Then divide both sides by the 9 to solve for x. 59. Let me touch that into my calculator and see exactly how many pennies that would be. 50 divided by 9 is it's about 550. 555 repeating. Notice it repeats. So let's round to the nearest penny. A lot of the ones that deal with money will want rounded to the hundredth place or the nearest penny. So that rounds it up to a 6. So $5.56 to be exact. All right, next thing on your note packet, shadows. This comes up in your homework some. It's a strategy for figuring out the height of tall things outside. If you can kind of measure the shadows, they should be proportional to the objects that are standing up is the length of their shadow. Now that only holds true if they're measured at the same time of the day, and it has to do with the angle of the sun should be the same, and so it has a little trigonometric background to it. But just know that shadows should be proportional. If you're looking at two things outside, a tree and a person maybe, you've got this tree casting a shadow on the ground, and then you've got a stick or some sort of other object that's measurable. You can reach the top of it where the tree would be hard to measure, and then you measure its shadow. The actual object should be proportional, here, that object, the tree, to the shadow, and then this object to the shadow. Those two things should be proportional when we use this strategy. So say we knew this shadow was, 10 foot long, and this shadow's 2 foot long. We could measure how tall this object was, say a stick in the ground or something. Say it's 5 foot. Again, we've measured at the same time of the day. We could then estimate the height of that tree. So it should be proportional, and you can do it in different ways if you're, again, questioning that. But my way, I would say the object to the shadow and the object to the shadow are proportional. So this is my unknown. I'll call that x, the height of the tree, and we'll just say we're measuring everything in feet. So the actual object to the shadow, here should be the actual object and then the shadow on the bottom. So 5, and then the shadow is 2. And that would let us then solve for the height of the tree by cross multiplying. So I'm going to say x times 2, that's 2x. 10 times 5, that's 50. And then divide by 2, and we should then know this tree should be about 25 foot tall, something we couldn't have measured, with our yardstick, right? We would have had a hard time measuring that, but these things are measurable. And so that's a strategy for measuring tall objects by measuring their shadows or estimating. The example I have here, next example, another one of these, says we have a 3-foot stick in the ground. So let's change this to 3 foot. And it's placed in the ground near a tree. And the measure of the shadow of the stick is 1.2. You don't have to draw these pictures, but it kind of helps me to visualize it. I think it helps sometimes if you do. So that's the first sentence. And then the shadow of the tree is 15.36 feet. And it says how tall is the tree. All right, so again, you might want to pause the video, practice that before we go on. See if you can set that up. But I would say the tree height is to the shadow, its shadow height, as this stick height is to its shadow length. And then that gives us a solvable equation. We can cross multiply and say x times 1.2, 1.2x, there's an understood little time sign between those. And then 3 times 15.36, let's see, I did that on your paper, it's 4.08. Then you always divide by what's on your variable. This 1.2, we divide to each side. Punch that on your calculator or do it by hand if you like. But you get about 38.4, and that's in feet. If we're measuring this, everything is in feet here. So that's the height of that tree example. All right, so that's the first page. Okay, next page. Another way we could use this, a proportional example, is whenever the Parks and Wildlife Commission, they do tags on different animals, they tag fish, they tag deer, different things. If you can find a good sample of that, and you know how many deer tags they gave out, or how many, I guess, taggings on these fish that they do, then you could figure out the population. So take a minute, pause if you need to, read that first paragraph. It says, how many fish are there in this pond? The Parks and Wildlife Commission has introduced game fish into a large pond. They have tagged some of the fish for tracking and studying. You are trying to estimate the number of fish in the pond. To estimate, you can catch a sample of fish, so you take your sample of fish and see how many of those are tagged. And it should be proportional to the larger pond. Like, you want to know what's happening in the whole pond, like there's a certain amount of fish, you know, maybe there's, I don't know, 1,000 fish, 50 fish, whatever. There's fish in the pond, and if like they tag 20 of them, then you can take like the sample should be proportional to that. So our smaller sample, you cut your smaller sample, and it will have some tagged and some not tagged. But it should be a proportional amount. Now, it won't be exact, perfect, you know, depending on how big your sample is, but it should give you an idea. It should be somewhat the same, proportional. All right, so say you catch 25 fish and 5 are tagged. The Parks and Wildlife Commission states that they have released 100 tagged fish. So knowing that, we can estimate that whole pond, how many do we think the total population would be. So, and again, I say this on each one, that this is not the only way to do this, but this is a method. The number of tagged in your catch, in your sample, we would call that. You caught some fish, how many of those were tagged over the total you caught, your total catch. That should be proportional to the tagged fish, and we know this because they asked the people that tagged them, they said, how many fish did you tag? So the total tagged, the official count, and they told us that in the reading, over, this is what we would never be able to know without this method, is how many fish are in this pond. Total fish in the pond. All right, so that's what we see in this. So it says in our little sample we did, we caught 5 tagged fish out of 25 total fish, and that should be proportional to the 100 tags that they put in the whole pond. What we don't know is how many fish are in the whole pond. That's what we're trying to figure out with this strategy. So then we could cross multiply and say 5x equals 25 times 100. Divide both sides by 5, and then that gives us 500. That would be our estimate for how many fish are in that pond or lake. All right, then you've got some U-tries. I'm going to go ahead and pause the video here and come back in with those, so please try to work ahead and do those 4 practice problems with proportions.